Hello everyone, welcome to my YouTube channel named ECE Scholastic. So I am Jasmine Vijitra, working as Assistant Professor in the Department of ECE, RMK College of Engineering and Technology. So in the previous session of control systems, we have seen topics like what is a control system, what are the types of control systems, transfer function definition, linear time invariant system definition, mathematical models of control systems, mechanical and electrical systems, force and torque balance equations, as well as voltage and current equations related to electrical system. In this session, we are going to see what are the steps involved in solving problems under mechanical, translational and rotational system, what are the assumptions, what are the formula connected to solve the problems, and finally how we are going to solve a problem under mechanical translational system. Okay, so the steps to solve the problems are, first step is we need to identify number of nodes. Okay, second one is we need to draw the free body diagram for each node, and from the free body diagram we are going to write the differential equation. With the help of Newton's second law, we are going to write the differential equation, and using the differential equation we are going to find what is the Laplace transform. So by taking Laplace transform, we are going to finally identify what is the transfer function for the given system. So the main step is to learn all these steps in order to solve the problem. Okay. The assumptions are, so the first step itself says that we have to identify the number of nodes, right? So we need to know what is a node. So the mass in the system is called as nodes. Okay. Mass in the system is called as nodes. And also the next assumption is, if the spring and dashpot are connected in series, we must assume that there is a mass in between the spring and dashpot whose value is equal to 0. Okay, which means that there is no possibility for a series connection of a spring and dashpot without a mass. Okay, so next is, if the mass is not provided with a displacement, we have to assign a displacement. Okay, so normally we will use the variable for displacement as x and y. Okay, and next is, on identifying the number of nodes, we can easily come to a conclusion that what is the number of free body diagram and how many number of differential equation is available. That is, if we are having two number of nodes, then we can say we have two free body diagram, so that we have two sets of differential equations. Okay, so after writing the differential equation, we will be applying Newton's second law. So after applying Newton's second law, we will be taking this Laplace transform in order to find the transfer function. Okay, so if the transfer function expression is not given in the question, okay, we need to assume the output displacement as the rightmost displacement of the diagram. Okay, next is, let's go through the mechanical translational system variables as well as the formulas. So for a mechanical translational system, the elements are mass, spring and dashpot. Input is force and output is linear displacement x. So the formulas related to masses. Mass is represented as m, F is the applied force, x is the linear displacement, and the formula is Fm is equal to m into d square x by dt square. Similarly, dashpot is represented as b, the formula is Fb is equal to b into dx by dt. If we have two displacements x1 and x2, then we can say that Fb is equal to b into d by dt of x1 minus x2. Similarly, in the case of spring, K is called a spring. The formula for opposing force offered by the spring is Fk is equal to K into x. If we are having two displacements x1 and x2, then the formula is Fk is equal to K into x1 minus x2. So we can come to a conclusion that mass is proportional to acceleration and dashpot is related to velocity and spring is related to displacement. Understood? Now let's see the Laplace transform formulas. So the most important formulas we are going to use is this sets of formulas, that is Laplace transform of a derivative is S. Okay. Laplace transform of a second order derivative is S square, which means nth order derivative is S power n. So Laplace transform is nothing but converting time domain signal to a frequency domain signal, correct? So Laplace transform of x of t is x of s. Laplace transform of y of t is y of s. Similarly, the Laplace transform of dx by dt is e by dt is s and x is x of s. Okay, similarly Laplace transform of dy by dt is s into y of s. So by heart all these formulas in order to solve the problems. Okay. Now let's solve a problem. So the question given is, write the differential equations governing the mechanical system shown in the figure and determine the transfer function. So here, which mechanical system this figure represents? The elements are mass, spring and dashpot, right? So this represents mechanical translational system. Okay. So we need to find the differential equations governing the mechanical translational system, and with the help of this differential equation we need to find what is the transfer function. So as we know, transfer function is equal to Laplace transform of output divided by Laplace transform of input with 0 initial conditions. Correct. So what is input for a mechanical translational system? Input is force, correct. And what is the output of a mechanical translational system? That is displacement, right. So what is the actual transfer function expression? But we know transfer function is Laplace transform of output to the Laplace transform of input. And also in the assumption itself I have told you, if the Laplace transform expression is not given in the question, you have to assume the output displacement as the rightmost displacement. So the rightmost displacement given here is x2. Okay. So we can say that Laplace transform of x2 is the output, okay, and input is force. So the force is given as F. So Laplace transform of x2 divided by Laplace transform of F. So all of these are in time domain, right. So what is the answer? x2 of s divided by f of s. So this is the required transfer function. This is the diagram of a mechanical translational system for which we need to find what is the transfer function, right. So the required expression for transfer function is x2 of s divided by f of s, correct. And here K1 and K2 is called as spring, M1 and M2 is called as masses, B1, B and B2 are combinedly called as dashpots. Also x1 and x2 is called as the displacement and f of t is called as the applied force, right. Now we are going to solve this problem. So what is our first step? Our first step is to identify number of nodes, correct. So as we know, mass is considered to be nodes, correct. So in this diagram we have two masses M1 and M2. Okay. So from that we can say number of nodes is equal to 2. Okay. And what about the second step? The second step is free body diagram. Okay. So since we have two nodes, we will be having two free body diagrams. So we are going to draw free body diagram for node 1 and node 2 separately. So node 1 is nothing but mass M1. Okay. So let's check what are all the elements connected to mass M1. So to the mass M1, the elements connected are K1, K2, B and B1, right. So all these elements will offer an opposing force to this mass M1. Also the mass M1 will offer an opposing force, correct. So we have opposing forces like F M1 and due to K1 that is F K1 and due to B1 that is F B1 and due to K2 that is F K2 and due to B that is F B. Okay. And the displacement connected to this node is x1. Okay. Similarly, for node 2, the free body diagram is given as So node 2 represents mass m2. Okay. So the opposing forces connected to mass m2 is, so the elements connected to mass m2 is k2, b and b2. Okay. The node m2 has an applied force f of t. Force f of t is towards right side direction, and all the other opposing forces are represented with an arrow mark heading towards left side. That is, the opposing forces are Fm2, Fk2, Fb as well as Fb2. Okay. So with this, step 2 is over. So what is step 3? Step 3 is we need to write the differential equation. So we are going to write the expression for opposing forces. So what is Fm1? So as we know, mass is related to acceleration. So how will you write Fm1? Displacement related to m1 is x1. Similarly, how will you write Fk1? So spring is related to displacement. So how will you write k1 into x1? Similarly, how will you write Fb1? B1 is equal to, B1 is literally connected to mass m1. So Fb1 is equal to B1 into dx1 divided by dt. Now what is Fk2? K2 is connected between nodes m1 and m2. Therefore it has two displacements x1 and x2. So how will you write K2? K2 into, we are considering first node, so the first displacement must be x1, x1 minus x2. Okay. Similarly, how will you write Fb? Fb is also between two nodes m1 and m2. Therefore, we can write this as b into d by dt of x1 minus x2. Okay. So similarly for node 2, we are going to write the differential equation. So for node 2, so what is our first opposing force? Fm2. So Fm2 is equal to m2 into d square x2 divided by dt square. So the displacement connected to m2 is x2. Similarly, Fk2 is equal to, K2 is between m2 and m1. So we will be writing this as x2 minus x1. Similarly, Fb is also b into d by dt of x2 minus x1. Similarly, Fb2 is written as, B2 is literally connected to mass m2. Therefore, it has only one displacement, that is x2. So B2 into dx2 divided by dt. Okay. So with that, step 3 is over. So step 4 is application of Newton's second law. So we use Newton's second law, sum of applied forces is equal to sum of opposing forces. So for node 1, we don't have any applied force. Therefore, the applied force value is equal to 0. So what are all the opposing forces? Fm1 plus Fk1 plus Fb1 plus Fk2 plus Fb. Okay. So what is the expression? Fm1 is m1 into d square x1 by dt square plus k1 x1, and Fb1 is b1 into dx1 by dt plus k2 is k2 into x1 minus x2 plus Fb is b into d by dt of x1 minus x2. This is equation number 1. Similarly, for node 2, we are going to apply Newton's second law. So as we know, Newton's second law is sum of applied forces equal to sum of opposing forces. So here we have an applied force f of t, and opposing forces are Fm2 plus Fk2 plus Fb plus Fb2. Okay. So I am going to expand these expressions. This is our second differential equation for node 2. Okay. So with this, our step 4 is over. So next is step 5. So what is step 5? Step 5 is taking Laplace transform. So taking Laplace transform for expression 1, what is the Laplace transform? 0 is equal to m1 into, what is d square x1 by dt square? that is s square into x1 of s. Similarly, k1 into x1 of s, also b1 into s into x1 of s plus k2 into x1 of s minus x2 of s plus bs into x1 of s minus x2 of s. So if you see this term, we have more number of x1 of s and few number of x2 of s. So we are taking x1 of s and x2 of s as a common factors outside. So while taking x1 of s as a common factor, what are the variables? m1 s square plus here is k1. Similarly here is plus b1 s. Next is plus k2. Next is plus bs. Okay. Similarly, when you take x2 of s as a common factor outside, minus is also a common factor. I am taking minus x2 of s into. So what are the variables? k2 plus bs. Okay. So I am rearranging this equation, that is x1 of s into m1 s square plus here s is a common factor. So b1 plus b into s and also the constants plus k1 plus k2. Similarly, minus x2 of s into bs plus k2. Okay, so left side is 0. So what is our required transfer function expression? x2 of s divided by f of s, correct? So we know we have two displacements, x1 of s and x2 of s. So our required displacement is x2 of s. We no need x1 of s. So we are going to find what is x1 of s in terms of x2 of s. That is x2 of s into bs plus k2 is equal to x1 of s into m1 s square plus b1 plus b into s plus k1 plus k2. Okay. 1 of s is equal to x2 of s into bs plus k2 divided by m1 s square plus b1 plus b into s plus k1 plus k2. So this is the expression for x1 of s. Take this as equation number 3. Okay. And what is our second equation? Our second equation is, what is the Laplace transform for equation 2? F of t is nothing but f of s. So f of s is equal to m2 into s square into x2 of s plus k2 into x2 of s minus x1 of s, correct? Plus bs into x2 of s minus x1 of s plus b2 into s into x2 of s. Now I am going to collect x2 of s and x1 of s separately. So I am taking x2 of s as a common factor outside. So the answer is m2 s square plus k2 plus bs plus b2s, correct? Similarly, I am taking minus as a common factor and x1 of s as a common factor. So the answer is k2 plus bs. Okay. So this is f of s. Now I am going to apply the value of x1 of s in this expression. That is substituting equation 3 here. What is the answer? x2 of s into, I am rearranging these terms, that is m2 s square plus b plus b2 into s plus k2 minus, what is x1 of s? x2 of s into bs plus k2 divided by m1 s square plus b1 plus b into s plus k1 plus k2 into this variable, that is k2 plus bs. Okay. So now I am going to take x2 of s as a common factor outside. Also I am going to take LCM. So that is m2s square plus b plus b2 into s plus k2 multiplied by this denominator, that is m1s square plus b1 plus b into s plus k1 plus k2. Okay, minus x2 of s, we have taken it outside. So what is bs plus k2 into bs plus k2? It is bs plus k2 the whole square, correct, divided by m1 s square plus b1 plus b into s plus k1 plus k2. Okay. So this is f of s. So our aim is to find transfer function is equal to x2 of s by f of s. So we are going to find the transfer function, that is transfer function is equal to x2 of s divided by f of s is equal to, okay, just we are rearranging all these terms, that is m1 s square plus b1 plus b into s plus k1 plus k2 divided by, so this is our required transfer function. Okay, so that's all about today's session. If you have any queries, please mail me. My mail ID is given in the description. Don't forget to like, share and subscribe. Thank you.